2.1, yay, chapter 2, functions, continuity. Number 1, this chapter is short. Okay? Short to the point, like, we're going to take a quiz on it next Wednesday. That's it. Short to the point of 4 sections, 2 of which we'll do tomorrow. That's short.
Wait, our test is next Wednesday?
Your quiz. You're going to have a quiz this chapter, not a test. Okay? Short to the point where it's a lot more conceptual than it is number manipulative. Alright? It's a totally 180 from last chapter. Alright? It's a lot more concept based than it is number solving equation based. So it's a lot less. It's actually, I think it's less work. It's more in your head. Okay? You understand what the crap you're talking about.
Yeah.
Stuff like that. Okay? So, here we go. First off, a couple of old definitions from stuff. Okay? A function is a relationship between numbers which each element of the domain is paired with exactly one element in the range. Alright, now, if you remember, and judging from your test, most of you do not, domain is a fancy word for x's. Range is a fancy word for y's. Basically, what you could say is a function is a relationship in which each x is paired with one y. Okay, that's what they are. X's to y's. Alright, now, what you've done in the past is basic stuff with these. Okay, real basic. Alright, today we're going to go into some details about those relationships. Alright, and that's where the bottom paragraph comes in. You don't have to write that. You can just summarize it if you'd like. You don't even really need to write that because we're going to go more in detail in a little bit. All functions map. Don't worry about what a map is just yet. Elements of the x's to elements of the y's, but they may differ in the way these elements are paired up. Okay, sometimes the x's are together, or sometimes the x's and the y's are related a little differently versus in one case versus another case. Okay, so we're going to learn today those different kinds of relationships and what they're called. Like I said, it's a lot more conceptual than it is hard work as far as the work to these problems go. It's also a lot of new verbiage. Alright, and sometimes the verbiage to this can be a little challenging as to why things are called the way that things they are. Just go with it for now. Alright, learn it. Don't worry about the in-depth details as to why it's called this or why it's that. Just roll with it. Alright, questions? Sweet. Next slide. Okay. What I want you guys to do, I'm going to pop up the entire slide. Whoops, too far. I want you guys to write one-to-one in this definition. I want you guys to write onto this definition. Don't worry about the stuff down here. Okay, just write the one-to-one, the ontos, and their definitions. Okay, one-to-one function is where each element of the domain pairs up with exactly one unique element of the range. Alright, now what I told other classes is this. Basically today, until you get the hang of it, if I say domain, think x. If I say range, think y. Okay? I think that'll help you. Do those two things. If I say domain, you think x. If I say range, you think y. So one-to-one means each element in the x's pairs up with one unique element of y's. What's unique mean? Not like the others. Very good, Mr. Galloway. Very good. Not like the others. You know, one of these things just doesn't belong here. Something like that? Yeah? Okay. Unique. Different. Alright. Just keep that in mind. Alright. On to kind of goes the other way. Alright, one-to-one talks about the x's with the y's. On-to kind of talks about the y's with the x's, because it goes like that. Each element of the range corresponds to an element in the domain. Each element in the y's corresponds to an element of the x's. Okay? Now, think about it like this. Okay? If you have x's over here, and your y's are on your right, right? So you dr domain range. Everybody see that?
Yeah.
Okay. Notice how D has a partner with 1, B has a partner with 2, C has 3 and 4. Everybody see that?
Yeah.
But you see how 3 and 4 are not unique with their partners. Going the other way? Okay, 3 and 4 each go with C, which is the same. It's not unique, which is why the right side isn't 1 to 1. Okay, see that? It's onto because every y has an x. That's basically what onto means. Every y has an x.
So
So?
So on this it said that like a y could have more than one x, but could an x have more than one y?
We're going to get there. Okay, we're going to get there. Over here, here's the difference. If you're 1 to 1, each x has a unique y. Okay, 1 goes with D, 2 goes with B, 3 goes with A. If you're onto, each y has an x. All right. Now, see C right there?
Yeah.
See how C is in your y box?
Yeah.
Since C doesn't have a partner, that means that this side is not onto because this y doesn't have an x with them. See that? Okay. This is an extremely rare case. Extremely rare. Has to be forced upon you, basically. All right. So just be aware of that. Okay? Now, the last one, kind of the same way, is kind of the easiest one. I don't know if it'd be better if I start with this one, but this is an example of one where you're both. Okay, 1 to 1 and onto. Also, just write down the definition. Don't worry about the box yet. Okay, we'll do that in a little bit. If you're 1 to 1 and onto, you have both qualities. Every y has an x, and every x has a keyword unique y. Okay? That's the key word to be 1 to 1 is unique. If you don't have unique partnership, then you don't have 1 to 1 in your function. Okay? Now, for right now, this is probably very confusing and overwhelming because it's a bunch of numbers, a bunch of letters, boxes, arrows, things you have not seen before. I get that. The rest of the day, we're going to take it back to stuff that you have seen before. Okay. Say the domain and range of each relation, then determine whether each relation is a function. Okay, now in there is something that we haven't talked about and how you determine if they're functions or not. Here's how that works, real quick. Good. Okay, write this down, big, bold. If x is repeat, it's not a function. If you have x is repeating, it's not a function, no matter what.
Like, so of all those numbers, so if it's like, so that would be a function because there's this -6 and this is not 6.
There you go. Okay. So first thing you do to figure this out, this is why when you get the hang of it, I'm going to draw a little box here. Hold on. Let me get my box set up. Fantastic.
So you didn't draw a box, but you really just put the square.
Yeah, I mean, I cheated about it, but yeah.
Zoomed in a little bit.
Yeah. Okay, so there's my x box, and what you're going to do is you're going to take all your x values, -6, -5, -3, -1, 6, and you're going to put them in that box. So -6, let's do black. -5, -3, -1, and 6, like that. Okay, this is starting that mapping that we did earlier, right? See that? That's what that's called. It's called a mapping. Okay, and then next to the right of it, you're going to do the same thing. Make a little box. And then you're going to take all your y values and put it in there. -7, 7, -9. Now, the nice part about this is you don't have to write repeats. Okay? Your y's can repeat all they want to. Alright? Your x's cannot. But if your y's do repeat, you don't need to write them in that box. Okay? Because we'll show that in just a second. Of why they do repeat and why you don't need to write them twice. And actually it helps you to not write them twice. Okay? Now, the last thing, like you probably guess, we need to do is the arrows. And how you figure out the arrows is this. This is the order pair. -6, -1. So from -6, and you draw an arrow over to -1. Okay? And then you do that for all of those ordered pairs that are in this set here. Okay? That's a set of ordered pairs. So then -5 goes with -9. -3 goes with -7. -1 goes with 7. And 6 goes with -9. Alrighty. Now, did your x's repeat? No, so that means it is a function. So you can go ahead and write down, is this a function? Function, yay.
That's all you have to know?
No. Now there's a last sentence, okay? Now, if it is a function, determine if it's 1-to-1 onto both of them or neither of them, okay? So here's what I look at first. I make sure all my y's have an x, okay? Do all my y's have an x? Yeah, okay, so that tells you onto. All right, and that's the part you have to learn. You have to know which one is which. Onto is y's to x's, 1-to-1 is x's to unique y's. Okay, that's the part you're going to have to just learn. All right, so y's, all the y's have an x, which means it's onto. Fantastic. Now, does each x have a unique y? No.
No.
Okay, because -5 and 6 both go up with -9. See that? That's how you know you're not unique and you're not 1-to-1.
So how do you pick which pair to go to which one again?
It's the order pairs up here. See -6, -1, so -6 goes with -1. -5, -9, so -5 points to -9. Okay.
So the number goes to the same number.
Right. So if you have an x, if you have two x's pointing to one y, you're not 1-to-1 because you don't have unique anymore. Okay, makes sense? Alright, now they're going to start throwing these to you different ways. Okay, sometimes they'll do it to you like a set of ordered pairs like we just had. Sometimes they'll give it to you like a table like this. You'll see a couple other different ways here in the next slide or two that they might present it to you with. But essentially it's the same way. You're looking at the x's and the y's and those guys' relationship to each other. Okay, so for this one, same question, same concepts apply. Determine whether it's a function or not. If it is a function, state whether it's 1-to-1, onto, both, or neither. Alright? Answer. Nestor.
Not a function.
Not a function. Very good. Why?
The 2's and the -1's repeat.
Very good. Look up top. Okay? Your x values go to -1, -2, -1, which is already here, and +2, which is over here. Okay? So if you draw that and you don't have to, whoop, my bad. You don't have to do this. I'm just going to show you real quick, okay? There we go. See, I have x's. This 2 goes to -2 and +2. This -1 goes with -1 and +1. See that? That can't happen. Okay, you can't have one x going to two y's. That's your x's repeating, which means you don't have a function. Okay, so for this one, if you ever see something like that, you don't even have to draw that. The second you see x's repeating, right here, and right there and there, the second you see that, it's not a function. Okay, Jack?
Are the questions going to be like the first example or the second example?
They could be like anything. They could be either one. Okay? Okay. Also, with the last example, with that, how I didn't say this, and I should have. You don't have to put it in that mapping. Okay, with the box and the numbers and the box and the numbers and the arrows. That does help, though. Okay, that really does help. All right. If you don't put it in there, you do at least. I'll show you on the next one. Have to write out your domain are these numbers, your range are these numbers. Okay. At the bare minimum, you have to do that. My advice: do the mapping though. If it is a function, do the mapping. It'll help you. Okay. And it's pretty easy anyhow. All right. So far, so good. A couple of new ways, at least one new way they can give it to you. Okay. So this one here is just a graph with a bunch of random points on it. All right, but that kind of goes back to that first one, where instead of giving you the ordered pairs like in a line, they give it to you on a graph. Okay. So the way you do this one is go count out those ordered pairs and then write them down, and that's your set. So you got an ordered pair. Let's see here.
Do you have to write them out?
You don't have to necessarily, because what happens?
It's not a function.
It's not a function. Very good. Okay, see right here and right here? Those coordinates are what? -2, 1, and -2, -2. Okay, see that right there? Oops. Repeating x's, which automatically makes you not a function. Okay, Lainey.
I'm just confused. Why is it and not just straight?
That's just the way they give it to you. That means nothing. Don't. It doesn't matter. It doesn't matter. Nope. As long as all you need to know is that somehow these two numbers are related that way. Okay. You don't care if the arrows go straight across or if they go cross up ways. It doesn't matter.
Oh, so you won't be drawing zeros?
Well, you will. All right, like on the first one we did. But as long as they match up to where they came from, like how this one's already done for you. So this one you would just go with that. Okay. So.
I don't get how you can have a range, but it doesn't have an X.
That's what we're going to get to, okay? You're exactly right, okay? We're going to get to that. You're talking about this last one here? Yeah, we're going to get to this. Okay? This one is weird, all right? As Mr. Galloway already kind of pointed out to us. This one is rare, all right? And what this basically is doing is it's forcing upon you one situation of this, okay? First off, see if there's any 1x going to 2y's, okay? So repeating x's. So there's none, right? -3 goes with 1, -2, -1, 0, 1. They all go to at least separate. They don't have two y's they're going to, which means they don't repeat, which means it is a function. Okay, so that's a good thing. Okay? Now, first thing you'd look at is make sure every y has a buddy. And it doesn't. Okay? See how 8 is all by its lonesome?
Yeah.
That takes away your onto. Okay? Which is rare. Alright? The only way something isn't onto is if it's forced upon you like this. Okay? Whatever math person wrote this textbook, they said, I'm going to mess with them. And they just made this box and they just put this one in here blank. And that's it. This didn't come from any real coordinate system because that doesn't happen.
Yeah,
Okay?
because if it was like y8, it would be a line.
Right.
It would be a
Exactly. Exactly. In the real mathematical world, that doesn't happen. Okay? So that's the only time the book / I will be tricky with you and try to mess you up, is if I already provide you a map like this. So be aware of that. Okay? If I give you a map like that, chances are it's not because I felt like doing it, it's because I'm trying to trick you. Otherwise, I'll just put them in as coordinates. Okay? Because I'm lazy. It's not on 2. Okay? So it's not on 2. It could be, but it's not. It's neither. Because the negative, right, because the negative 1 and the 1 go to 6, see that? So this one isn't either.
What's the difference between neither and not a function?
Not a function means you have x's repeating. Neither means you don't have x's repeating, but they don't meet 1-to-1 or onto. Right. Okay? Alrighty. Now, real quick visually, take this, 1 0 here, and instead of going to 6, put it to 8. Then it's 1-to-1 and it's onto. That's a both. Okay? Whenever you have boxes, and it's 3 arrows to 3 numbers, and they're not crossing, or they can cross. Cross is a bad word, sorry. And they're not sharing. That's the one I'm looking for. Okay? If nobody's sharing a number, then it's both. Okay? Right then. It can cross, that's okay. But if they share, that's not good. Alrighty? Everybody good so far? I know it's a lot of concepts to take in. Everybody good? We're going to skip vertical line test, move on to this. Okay? Now, discrete and continuous. It's very simple words. It's actually, the definitions are actually super easy. You just have to learn them. Discrete relationships is a relationship in which the domain and range is a set of individual points. Namely speaking, everything we've done so far has been discrete. Okay? Because it's been points. Either those points have come to us as ordered pairs, or in a table, or already forced upon us in a mapping. Okay? But it's just been individual points. That's discrete. Continuous is like you guys would think it is. It's a relationship that's continuous. Okay? So x's, which is the domain, having an infinite number of elements. So the numbers you have in your x values can go on forever and ever and ever. These can be graphed as a line or a smooth curve. Dimitri, I'm going to steal this real quick. Thank you. See this paper? These are full of continuous functions. Because they're all what? Exactly. They're all lines. They're all lines. They don't end. That's continuous. Okay? You can draw them in a line or a smooth curve, which we'll get to. We'll get to the smooth curve ones. Okay? So that's how you know whether something is discrete or continuous. Discrete points. Continuous lines, smooth curves. Backing up real quick. That's a continuous function. Okay? See how it's this nice smooth curve? Whoop. Okay? What's that called? Anybody know?
Parabola.
Very good. Next chapter, right there. All kinds of parabolas. Yep.
And you can do graph that on your calculator.
We could. We're going to. All day, every day. October is going to be parabola month. Be ready. Which would make November what? Polynomial month. Well, you'll learn in November.
Those ones where it's like
David, you will find out.
2x squared plus.
Bigger than squared.
Cubed.
Your cubes, your fourths, your fifths, yeah.
Ah.
I know. It's like we're growing up.
Dude, why'd you just write your name?
Everybody good? Yeah, yeah. Okay, so graph the following equation, determine domain and range. This is super easy. Super easy, okay? Number one, you don't have to actually graph it. Okay? You gotta just think about it. But I am gonna throw a quick graph of it up here. 1/2 x minus 3. About like that, right? Great. Now, domain. So.
The slope is positive, so.
Oh shoot, my fault. Yeah, thank you. Whoop. How about that one?
Yeah.
A little better? Okay, cool.
Yeah, it's a little.
Alright, now, obviously this one goes to continuous, yes?
Yep.
Okay, y equals 1/2 x minus 3. This is a continuous relationship. There is a relationship. Here's what this means. All the numbers on your x's and your y's, okay? If you have an x, it has a y, okay? The relationship from this x is this. Let me see here. Haley, pick a number. 5. The relationship between 5 and its y is you multiply it by 1/2, so 5 halves, subtract 3 off of it. Okay, so what would that be? 4 halves? 4? No, 5. 5 halves, right? 5 times 2, 5 halves, minus 6 has negative half. I can't do math. Okay? That's the relationship between those two. Okay? Water Cotty, pick another number. 7. You guys are evil on me. Same thing though. 7 times 1/2, minus 3. That's 7's y.
I
Okay?
got you. Can you just put that?
Tenius, be evil.
Oh,
Evil, evil. Evil, evil.
Oh, evil, evil. 413.
Not evil enough.
Really?
Yep. Wagner. Evil, evil.
Oh, evil, evil?
Yeah.
Oh, I got you.
Are you sure?
Sure.
Negative 69.
Still not evil enough.
I got you.
Marts. Evil, evil.
Negative 487.
Still not good
I
enough.
got you.
Tenius.
0.
Nope. That's nice.
That's what I was thinking.
Dimitri.
Oh, I got one. I got one.
3.21.
I got one.
78,000.
Stop.
I was going to give you a fraction.
We're going to go do it, Wags. That's what I want.
Negative 20 over 27.
Okay. Evil, but I like it. Negative 20 over 27. Process doesn't change though, right? You times it by 1/2, you subtract 3 off of it. Okay? Now, is there any number in the universe that you can't put in here, times it by 1/2, subtract 3 off of it?
No.
No, there's not. Plug in 0. 0 times 1/2 is 0, minus 3 is negative 3. That's why this x's, if you think about the x's on this number line, that's why that line goes left and right as far as it can. Because there is not a number,
Oh, thank you.
there is a number that you cannot put in there. Domain is your x's. So since there isn't a number you can't put in there, that means you can put them all in there, which means it's all real numbers. Okay? That's how you know. If there's a number that I cannot put in there, and for most of these, your domain will be all real numbers. Okay? Alexa?
So would range be infinite?
Range is going to this one be infinite also, all reals, yeah. Because see how the graph goes as far up as it can and as far down? Okay? Same way. You change your thinking from range to y's instead of x's.
But with the parabola.
Hang on.
The correct.
Laney.
I'm just confused. So, I don't even know what I'm gonna ask. Like, I guess I just need to like look over it more, but how to tell which one they are.
That's like 1-to-1 and on to and
Yeah.
okay. Once you go past your it takes a little practice, honestly. Okay. Once you go into the graph mode of it, it's a little harder to look at because you had to mapping's really hard. Okay, so don't worry about the graphs for them too much. Just keep looking at the maps for homework. All right. Stone.
I usually don't like this, but I really need to.
Go. Okay, everybody good? Now, as Mr. Galloway goes PP,
Nope, number 2.
we're going to do another one of these, all right? I'm going to clean this slide off.
Wait, so is that?
Yeah, that's all you got to do.
What about the function?
It is.
Or like, which one?
It is a function.
You know, like,
You just write it's a function?
Yeah.
you don't write 1, 1 or both?
Oh, it's both.
Come on, Andy.
Well,
It's both. My fault, my fault, my fault. Think about it, think about it, think about it, okay? Each y has an x, each x has one y. Right? As it goes like a line like that, see that? Think about them in the number lines, okay? Each y, go up here, down here, has an x value associated with it, okay? And each x has one unique y. Okay? I'll show you one that doesn't. Okay? Instead of y equals 1/2 x minus 3, we'll make it y equals x squared plus 2. Now, you guys don't know how to graph that yet, so I'm just going to do it for you. All right? Okay? Your domain is, and that's your x's. So is there an x that you can plug into that function, or you cannot plug into that function? Is there an x in the number world that you cannot square and add 2 to it?
No.
0 squared is?
0.
Add 2.
2.
So 2.
Yes,
Okay.
man.
So there isn't one. There isn't a number you can't plug in, which means your domain is
All real numbers.
all real numbers. All right?
Oh, so it's the x squared on the parabola?
Right.
So, the first one was all real numbers for both because you can plug any number into y or x.
And you'll get, no, you can plug any number into x, and you'll get all the numbers back out. Okay?
So-
Hang tight, hang tight, hang tight, hang tight. This will make sense in just a sec, okay? Okay? Hang tight. Alright? Now, for this guy's range, this guy's y values, I want you guys to do this, okay? We might push your homework quiz off a day.
Oh, thank you.
Okay? I think I'd rather do this. We'll push it off till tomorrow. Okay?
Great.
Yeah, you're lucky. Anyways, your range. I want you guys to plug in these 3 numbers. Okay? 0, 1, -1. Okay, so when x is 0, what y did you get?
2.
2. Good. 0 squared is 0. 0 plus 2 is 2. When x was 1, you got what? 3. When x was -1, you got 3. Right? -1 times -1 is 1.
What?
Right? -1 times -1 is +1. 1 plus 2 is still 3. Okay? Everybody see that? Okay. Now, 2 things come from this. Number 1, when we go back and talk about our function as being 1-to-1, onto both, or neither, see how these 2 x's go to the same y? 1 and -1 both go to 3. Which means it's not. No. It is a function, but it's not.
It's not 1-to-1.
It's not 1-to-1.
Or both.
Or both.
Wait,
There's
so it's
one.
not
Okay.
But wouldn't like -1 be 1 for y? Because -1 plus 2.
You gotta square it.
That's it.
You gotta put it in parentheses. Yeah, just put it in parentheses. Okay. So, Abby,
So onto is the, like,
if you can graph it, it's gonna be onto. All right. Because you're gonna have all the y's will have an x. Okay. The only way it's not gonna be onto is if I give you a map and there's a random y without an arrow pointing to it. Right. Right.
and then 1-to-1 is all x equals 1.
There you go. Yep. Okay. Now, that's your okay. So that's for 1-to-1. Everybody see that? Now, I want you guys to tell me how am I going to get a y value of 0. What number can you plug into there and get a y value of 0? Negative 2? What's negative 2 times negative 2? 4, which add 2 to that, that gives you 6. So negative 2 won't do the trick. Jason? There isn't one. There isn't a number that's going to give me a y value of 0. Because no matter what you put in there, you still got to square it, you still got to add 2 to it. Okay? If you had a shot at it, it was with one of these 3 right here. Okay? It would have happened right here. Okay? Same concept. I want 1 as my y now. Will that ever happen?
No.
No.
It can't be more than 2.
There. Okay? Less than 2.
Less than 2.
Less than 2. There you go. Okay? 1.99999999. Still ain't happening. Okay? Because, look at the graph now. See how it points up this way?
Yeah.
This is my y-axis, ain't it?
Yeah.
So my y's go up this way. So what's my lowest y value I'll ever have? 2. Lowest y value you'll ever have is 2. So when you go to your range, you got to put that. Okay? So my possible range are y's that are greater than or equal to 2. Okay? And there's a lot more going on with that one than what we're going to get into today. Okay? Back to the top, though, determine whether it's 1-to-1, onto, both, or neither. It is onto. Okay? Any function you can graph will be onto. Okay? So if it comes from a graph, it's onto.
Will parabolas only come from a graph because they would be not a function otherwise?
Not necessarily. I could set it up where I take the points off of that parabola and put it on a table. Okay? Jack?
So you know how you like did the wishbone kind of thing?
Uh-huh.
Is that because it was x squared?
That's exactly right. Yeah.
So if it was like the first one where it was like a
line.
A y equals mx plus b formula.
Uh-huh.
Would you just graph the line?
Yes.
Like,
Yes. Yeah, you guys don't know how to graph that yet. Okay? Use your graphing calculator if you need to. There's a lot going on here. Okay? There's a lot going on here. Okay? A lot of things, a lot of concepts that are going to get mixed in with the rest of this course. Okay? This is kind of the stuff we're going to talk about the rest of the year. Okay? Is these different functions and what they mean as far as their numbers go. Okay? Ostov.
So is the answer just onto?
Yes.
Is that the only thing?
Your domain, your range, and onto. Yeah.
Domain,
Why'd you pick 2?
range is onto.
Yeah. Domain, range, and then it's onto. Yeah.
So the full answer is domain is all real numbers, the range is
Y is greater than or equal to 2, and that it's onto. Okay? Jack?
one last question.
Sure.
The number, the 2, that will change.
That could change, yes.
And then you'll just for the range, it could be whatever that last number is.
Yeah. More or less, yeah. And this will make more sense as we move through this chapter and move on to other things. Okay. It could move that n number here does have a lot to do with your range. I could also make this a negative in front of this x squared and it flip it down. Okay. So then your y's would have to be less than or equal to 2. Okay? So there's a lot of moving parts going on that throughout this chapter plus the next chapter, especially for parabolas here that we're going to talk about. Okay?
So for everyone, it's just those 3.
Pretty much, yeah.
function is just
Yep.
those 3 answers.
Okay? Anybody else have any questions to delay your homework quiz?
Yeah.
So,
Wax.
edit. We got 2. We got 2 x 2.
Because it's the first Y I can hit. Right there. See that?
So that you just
It's the smallest Y you'll ever
Why can't
hit.
you put 1?
Hmm?
Why can't you put 1?
I already said that. Now you guys are being silly. Shields.
What if that's on y equals 1 or 2x?
Yeah.
What would be the range then?
That range would be all reals.
So that's the all
Right, because see, you know how the arrow was drawn? Let me draw it real quick. Kind of like that, right? See how you hit all these y values? Extend this all the way left, up, and then extend this all the way right. Okay, you hit all those y values. On the parabola, you don't. Because see, it starts right here and then it goes up on both ends.
Okay.
So that's your main difference. You all done? Thank you, dear. Need a pass?
No.
All right. All right, last, we do have a little bit more to do, okay?
Is this the last one?
This is the last one. All right, now, given f of x equals 2x squared minus 8, find each value. First one, f of 6. Second one, f of 2y. At some point, a teacher probably taught you guys this. Okay, everybody remember this? Looking stuff? Okay, I know I've taught some of you guys in here this. And they probably all use the machine analogy. I'm not a big fan of that. Here's what I like. What's given to you is kind of like your instruction manual. Okay? So kind of like we did with the last one, when we plugged in 0, 1, and 2. We squared it and we added 2 to it. Here you're going to do the same thing, except this, you're going to square, double, and subtract 8. Okay, everybody see that?
36.
So you're going to square whatever you have for x.
72.
You're going to double it, and then subtract 8 off of it.
So
Okay.
it'd be 64. So minus 8 would be
Yeah.
7.
Right. Okay, so for this one, what are you going to do that with? You're going to do it with 6.
So you basically just plug it in.
That's basically it.
And then whatever gets your answer.
Why is it not 64?
I'm pretty
It is 64.
I had 64.
I'm pretty sure it is, yeah. Okay, so follow your order ops from there. You plug in the 6 to this part. Listen. You follow your order ops out of here. Okay, square 6.
36.
You double that. Subtract 8.
Wait, why don't you do 2 times 6 first?
Order ops.
Isn't it?
I just put it in my
Then-
calendar.
Right, parentheses. There's nothing inside the parentheses.
But
It's
two-
just 6.
2 times 6?
That's multiplication. Parentheses is operations inside parentheses. So then you go exponents.
Experiments.
So 36. Okay? Yes. Same concept, except you plug in 2y instead of 6 on this one, right? Okay? You gotta think back a little bit. What's 2y times 2y?
4y.
That it? 4y squared.
Square.
Okay? Because y times y is y squared, right? Remember that? All right.
Wait, why do you-
Because there's a 2 in front of the term. That 2. There it is. Okay. Now what's 2 times 4y?
8y squared
8y squared
minus 8.
minus 8.
That's your answer.
The end. Yep. Not like
Done with that.
terms, correct.
That's just your answer?
That is your answer.
So that's separate from the function?
Correct. That's two different questions.
Okay.
Tennis.
Will we ever have to have these, will they ever connect those two questions? Like, will we ever have to find like the function to get to the next part?
No. You. For now, these are going to stay very basic like that. Okay. For a couple chapters, these are going to stay very basic. All right.
So this is just another part of the lesson?
Yes.
It doesn't
This is
have
totally separate. Yeah, totally separate. All right.
When do we read our testament?
Wednesday.
This Wednesday or next Wednesday?
This Wednesday.
Oh, good question.
Okay.
It's Wednesdays are weird.
All right.
Yeah.
Homework, people. 91, 92, 14 through 19, 32 through 34.